Hi, I'm Mike Austin, Service Manager with the Gorman Rupp Company. This video and future videos will inform and instruct into the operation and troubleshooting of self-priming centrifugal pumps. Before we get started, let's review the piece of equipment we'll use for our priming demo. It is the glass face pump. The glass face pump consists of our very own 11.5 A3 E1/2 single-phase unit, driven by a variable frequency drive. It is the exact same 11.5 A3 that we build on a regular basis here at Gorman Rupp, with one small exception. We have taken this particular pump, the 11.5 A3, and we have sectioned the volute casing at the same location where the wear plate is installed. We have mounted a bulletproof Lexan face and maintained the same clearance between the impeller and the Lexan face. With this glass face, we can now see what occurs inside during operation of the glass face pump. Included outside of the pump itself is glass piping. Mounted to the suction line of the glass face pump is a vacuum gauge. Mounted to the discharge side is a pressure gauge. Also included in the glass face pump is a stroboscope to measure speed. With the speed of the pump and with gauge readings, we can then plot condition points on a curve and troubleshoot accordingly. Let's go ahead and get started with the subject of our video in priming. We'll open both air valves, inducing air back into the system, allowing the liquid to fall back to the amount of water that we normally place inside the pump for priming. For those of us that are familiar with self-priming centrifugal pumps, we know that we must first fill the volute with water. We can now start the pump and watch what actually occurs inside of the pump during priming. After we fill the volute casing with water and we energize the pump, the impeller turns in a counterclockwise rotation. The initial prime of the pump is slung through the volute scroll, or the ever-increasing water channel, into a pressure cavity or a discharge chamber inside the volute. Inside this discharge chamber, the air and water separate. The heavy water falls back down through a recirculation port, and the air then is evacuated through an open-ended line or through an air release device. All the while that we recirculate the water inside the casing and remove the air from the top, we create a low pressure at the eye of this impeller. Due to differential in pressure, atmospheric pressure that we live around every day is higher than the lower pressure created at the eye of this impeller. Due to that differential in pressure, atmospheric pressure outside begins to force liquid up the suction pipe. As liquid moves up the suction pipe, it pushes all the air ahead of it into the volute casing, where it is handled through the recirculation process. Again, the air is handled off the top, and the heavy water recirculates back down into the volute scroll area. I'll close this valve right now and create a suction line capable of pulling a vacuum. Ahead of it moves the air, pushes it into, handles it through the recirculation process, and once the water arrives, the pump then goes to complete operation.
For more information on pump hydraulics, equipment, or application engineering, watch Gorman Rupp's YouTube channel and visit us at grpumps.com.